Hey everyone, welcome back to the YouTube channel of Developers and Codeforces. Today we are here to discuss the problem Tenzing and Pose, which is a part of recent contest of Codeforces CodeTON round 5. So in this question we will be given a unballs and the color of ith ball is from left is AI. And we can do an operation n number of times, and what is the operation that's left to indices I and j such that I should not equal to j, I should be less than strictly less than j. And obviously that should be between 1 to size of a, and AI is equal to AJ means the color of both balls is same. Then we can remove all elements from AI to AJ means all elements from index I to index J from the array, and decrease the indices of all elements of the right of AJ by J minus I plus 1. That simply means that concate the remaining part. So Tenzing wants to know that maximum number of walls that he can remove. So like if we see in first test case, so these two balls are same color, both color is same too. So we can remove two. That will be we have removed two balls. Now we have this array. Then we can remove these two. So we have removed two air. That is four. In this case, one two one two. Either we can remove these three balls. Either we can remove these three balls. Why? Because the color of this ball and this ball is same, so we can remove these three, or we can remove these three. Because if we remove these three, then remaining will be only two. So for this, answer is three. So like if I write a simple uh, array, one and two and two, okay, three, four, five, six, seven, eight, nine. So what will be the answer for this one? Uh, there are only can two type of pairs we can choose, either this and this, or this and this, because these pairs are only exit which have same colors. So if we remove from this to this, then we can remove elements 1 2 3 4 5 6 7, and if we remove from this to this, then we can remove 6. So what will we do? We will remove from this to this, then we can remove 7 elements, and remaining elements will be 7 8 9 2. So we cannot remove any elements from this one, so answer for this one will be 7. So now, first thing, that greedy cannot be worked here. We have to go for DP solution. But why? Why greedy cannot work? So, as a simple greedy solution, we can think that we will proceed with the highest with the maximum distance. Like if one is here, one is here, two is here, two is here. So this distance is distance one, and this is distance two. So we can say that okay, we will remove first this one, then if possible, then we will remove this one. So simply means that we will start with processing with the highest distance with the maximum distance. But there is a issue. Like if you make a 1, 2, 3, 4, 5, 6, 1, and okay, let me make it a little bit shorter. So 1, 1, and 5, 5, and 2, and 2. So 5, 1, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, and 14 and 15. Okay. So in this question, in this sequence, you can see that from 1 to this one, there only can be three possibilities: 1 and 1, 5 and 5, 2 and 2. 1 and 1, 5 and 5, and 2 and 2. So distance from this one to this one is 1, 2, 3, 4, 5, 6, 7. Okay. So for this one, that is 7. For this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. For this one, 1, 2, 3, 4, 5. So if we proceed with a greedy solution, then we will proceed first for this one. Okay. So what will be the remaining sequence after this one? That will be 1, 10, 11, 12, 13. From this to this, we have removed. So we have removed 9 elements, and the remaining will be 14, 15, and 2. and we cannot remove any element from this one, so the final answer will be 9. But instead of this, if we remove 1 and 1 from this to this, so we have removed 7 elements. Remaining sequence will be this, and in this sequence we can remove from this to this. So 1, 2, 3, 4, 5. So we can remove 5 elements also. So total sum of this is 12. So instead of that greedy solution that was giving 9 as our answer, we can find a solution in which we can get 12 as our answer. So that is how we cannot apply greedy. We have to apply DP. So I'm going to explain an iterative DP. So what we will do for every element like 1, 2, 3, 4. This these are the elements, not index. For every element, I will store that indexes of this element. Like one is occurring on third index, on fifth index, on 10th index. Two is on first index, fourth index, seventh index. These are the vector of elements, like as we do in our graph. So these all storing the indexes of every element. Now what we can do, we can iterate from I from 0 to n. And what will you do? Like just think that this is our array and your eye is pointing here. Then you can say that just imagine that we are getting x is our maximum number of elements which you can remove from this part. From this part, we can remove x elements, and that is the maximum. Now, what will be the maximum from this part? So for that, what we can do that like if this is 1, then we can iterate for every index of 1, and we can say that the maximum on that index, like just think that here is 1 is written here, then we can say that answer for this one can be answer for this one can be x plus distance from this distance, x plus this distance. This is the maximum number of elements which we can remove before this one. Are you getting point? That what we are doing for any particular point, we know that x number of elements we can remove from the before this one. This is the maximum. Now what we can do after this one, we can iterate for every indices of this element. Like if this is z, then we can iterate for every indices, like z is occurring here, z is occurring here, z is occurring here. So what we can do that we can update like dp of this index, like just think that is lambda 1. dp of this index can be maximum of lambda 1 and x plus this distance. Okay, dp of lambda 2 is pointing to this index, that can be maximum on dp of lambda 2 comma x plus this distance. That is a simple dp solution, like how we are iterating. So if you see the code, that will be more clear. That first of all we are taking the array. This is the dp state. I'm calling that maxi. Then maxi of every index is initially 0, and vector of array of I am inserting I here. That is the index of this array of I. Then I'm decreasing, sorting the in the descending order every indices. Why? Because just think that 2 is written here, 2 is written here, 2 is written here, 2 is written here. This is first index. This is fourth index. This is seventh index. This is eighth index. So VTR of 2 will store 1, 4, 7, and 8. Now, if you are iterating on every point, that if you are iterating for every indices of 2, like just think that you are on fourth 2, and what we are going to do, that 4 auto x VTR of 2, and you will iterate for every 2. In that case, you will start iterating from first. Okay, but that will make a issue in our TL, that will generate a TLE. So what we can do is that we can sort in descending order this one and remove the, like in sorting in descending order, that will be 8 7 4 1, and then every point we can remove the pop back from this vector, because we have iterated this first element. Means that if you are on first element, then you can remove, means if you are on first index, then you can check for every element from 8 7 4 1 and pop back this one after that, because after that you are going to on fourth index, then you can check only for 874. After that you are going to seventh index, then you can check only for 8 7. So I'm sorting the or vector in descending order. Then this is the current zero. What is mean? It will give us that what will be the this x. This x is that curve. That is giving that the what is the maximum we can get before this index. So for every index, I'm popping back the popping a element from the last of the vector. Then I'm iterating for every vector. Basically, this is not making any sense. If the flag is max equal to x, that is basically means that if anywhere we are not going to update any uh, maximum after that, what it means? Like just think that you are on fourth index, okay? On the maxi of 8, that was previously just think that was 7 before this one, okay? Then you are iterating for this fourth, and after this one also, that is 7. That means you are not making any change. 4 is not contributing anything. So there is not any significance if you are iterating for 7 and 4. So I am doing that only for not getting any TLA type of things. So I'm updating our max with max of I, comma curve plus x minus I plus 1. That is distance between this x and current index. That is I. So current is the maximum number of elements which you can remove before this I, plus x minus I plus 1. That is the distance between that I and that x. And or final answer can be maximum in any maxi of I. And what will be the current? That will be also same. So in last we will going to print ans. So I hope you all got it. You can go the code in description. So in the next one, until then, happy coding. Bye bye.